There, now we're doing the last one on curve sketching here. With our curve sketching, we are going to, we're not given the equation this time, we're just given information about it. So let's go along here and let us go and just start doing our what we can do. And I'm going to do red today. And so let's go start putting the information we have. So first thing I know, x-intercept 2.2 right here, and negative 1.8. Y-intercept negative 2.5 is here. Asymptotes at 2 and negative 2. Let's see if I can get some good lines going on the go. I'll do a line here at negative 2 asymptote, and at a positive 2, and a horizontal asymptote at y equals negative 3. Okay, so now all the basic stuff is taken care of now. Pen. Okay, so now, next calculus part. F prime of x is not 0. That then implies that there is no max or min. Max or minimum. But it says when x is less than negative 2, between negative 2 and 2, and bigger than 2, so that means everything except the asymptotes, the first derivative is less than 0. Less than 0, that means negative. So if it's less than 0, that means f is always decreasing. Always going downwards. Decrease. Okay, next thing, f double prime at 0 equals 0. This is a possible point of inflection. We have to do our sign charts to see what's going on, make sure it changes sign. So here is f double prime, and f. Put our asymptotes on, our zeros for the second derivative. So this is not defined. This is 0. This is not defined. So now I have to look and see what's going on. Between at less than negative 2, it is less than 0, which is negative. So this is negative, concave down. As is between 0 and 2, negative, concave down. Bigger than 2, positive, concave up. And then negative 2 to 0. Again, is positive, concave up. So concavity is changing, so that means this point here is definitely a point of inflection. The function's always decreasing. So if we look at this part here between 0 or between negative infinity and negative 2, it's always decreasing and concave down, and it does not cross the x-axis, confined by these asymptotes. So it's got to look something like that. When I look at between negative 2 and 0, concave up through this value, through this point, and yet I have to have inflection. So here we're going to come down here, curving this way, inflection point at the y-intercept, and then it changes concave down. Concave up, the concave down. And then finally, we know concave up, concave down is here. Bigger than 2 is always concave up, but always decreasing as well. And it's got to go through here. Well, I have my asymptotes to help guide me. It's going to come down here, decreasing, still concave up the whole time. It looks something like that. And one of the questions people ask me, well, this is a horizontal asymptote. How can we go through a horizontal asymptote? Well, horizontal asymptotes are different than vertical ones. Vertical ones, they can never cross. Horizontal asymptotes really mean as x values get really big negatively or really big positively, the curve or function starts to resemble that line. These are not really big numbers. These are small numbers. We don't really care what's going on. So this is perfectly fine to cross a horizontal asymptote at small relative numbers.